Retirement planning, time value of money review. Okay, in this short video, we're going to look at the problem that we just solved using the financial calculator. Recall, it was assuming John wants to retire 18 years from now, inflation adjusted equivalent of $45,000 additional annual income above benefits provided by a government or employer pension, payments at the beginning of each year. As John and the financial professional discuss his retirement, the two agree to plan for 20 years of inflation-adjusted income in retirement. Annual inflation is stable at 2.5%. John's portfolio is earning 6% annualized after fees. How much money will John need today if he wants the entire amount in place at the beginning of his retirement? How much money will John need to save every year or month starting today if he wants the entire amount in place at the beginning of his retirement? So as I mentioned in that video, we have an Excel sheet embedded in there. So I just wanted to make a separate video to quickly review this Excel sheet that I put together as a little model, because some people like to learn things in Excel, and indeed it's just a useful sheet to have. So here we can see that we started the annual income today is $45,000. We need to calculate what it's worth 18 years from now. So we can see our input cells, annual income in today's dollars, years until retirement 18, 20 years of retirement, net return on the investment account, 6%. Inflation is 2.5%. So we have our Fisher equation, 1 plus the investment rate divided by 1 plus inflation minus 1 times 100 gives us 3.4146% on the real rate of return. So you can see what I did here. This is step number 1. What is $45,000 today, 18 years from now? So again, you can see here on the left-hand side what was from the PowerPoint slide when we were solving it. But here I have it in Excel. So we need to be in the ending mode. So that is a 0 nomenclature when we're using Excel. Number of years is 18. Periods per year is 1. So number of years times periods per year, n is 1. 2.5, we're using that inflation rate. For step number 1, the present value is $45,000. There's no payment. So here you can see equals future value divided by B11, which is the inflation rate, divided by B9, which is the periods per year. That's something that you have to do in Excel. And then it's just asking you to put in the other inputs, compute the future value, 70,185. So then step number 2 was down here. Now we're in the beginning mode, so you can see the nomenclature for the Excel. We have to have a 1 as an indicator, 20 years of retirement, payments becoming at the beginning of every year, 20 years of retirement. Here we use the inflation adjusted rate of return because we have 6% investment return, 2.5% annual inflation. The payment is that $70,185, which is coming down from our future value calculation in step number 1. No future value because retirement will be over. So again, we calculated the present value, 1,039,567. Then you can see, so that's basically rounded. There's a little bit of rounding there. So in the step number 3, we want to calculate how much is that in today's dollars. So that's 18 years from now that we want to retire. Here we use the nominal investment rate because it's a saving and investing. That's the future value. So we calculate our present value. That's the lump sum that we needed today. And indeed, we went through a couple of problems at the end saying how much would be the annual payment if we had a savings and investing, and how much would be the monthly payment if we had a monthly savings and investing plan. So again, that's just a little Excel sheet. There might be a little bit of small rounding differences there from the financial calculator. Just a bit of rounding. But that's an Excel sheet that recaps all the calculations that we did in the video with the financial calculator. Here it is, a quick review in Excel in terms of the Excel formulas. And this Excel sheet should be available for download in the Learning Management System. Thank you.